all of them in the
And it's like-
corner. So I'm like, okay, fine, like,
already
they can
got
stay at the corner.
Yeah.
Like, I was like, I'll be fine. And then he kind of think I did it a lot later than it's usually do, because when
So it's
they
just
came in, or
Okay, why are you talking
so like, they're like, there was a bright light on, and like, turned off.
You know what I mean?
Red.
While you were in there?
They started just flying around, and I like, I swear, I think it's like any other thing.
All right, so we start our Tuesday.
So scary. I just kept my head. Ducking like. One of them.
Did you hear my question?
No,
So.
I don't usually listen to you often.
That's not very kind of you. I'm having a really.
Oh, okay, so you have my attention.
Thank you. So Joycelyn's now on the list for group projects. Would she join our group or the group project?
I didn't put you in a project?
No.
Oh, yeah,
Cool. Thank you, Tom.
sorry. I didn't mean to exclude you from a group project. All right. Welcome to Tuesday. We're gonna start unit 2, new day or new week, new unit here. We are, again, I'm trying to make more room at the end of this course for large language models and stuff, new modern stuff. So we're gonna actually be combining what was in unit 3 and what is in unit 2 together. So unit 2 is on some cleaning and manipulating data, and unit 3 is on some regression and correlation sort of stuff. And then with the cleaning and manipulating data, we do some visualization. A lot of this is stuff I think you have in other classes in some ways. And I just want to do kind of a brief coverage. And now since I'm combining these units, we're going to do an even briefer coverage. But we're going to be kind of looking at these sort of basic data analysis tools that are really not machine learning, I would say. But you have to do them before you can get to machine learning. So you have to like clean and set up your data before you can do machine learning on it. There are whole courses on how to clean, organize data, and set this sort of stuff up. If you take our graduate, our master's in applied data analytics, there's a whole course on this stuff. Similar to visualization, we have a whole data storytelling course. Is anyone in Chris's data storytelling course now? So again, we have a whole course in using Tableau to do that. We're just going to do looking at very basic stuff in this course and doing it in Python for that. Now, regression and correlation, I think you probably know what correlation is. We'll talk about it, make sure we're clear on what a correlation is. And we'll talk a little bit about linear regression, which is kind of the basic model. Again, if you're doing linear regression, you usually, I think you're often doing it like just in Excel or a spreadsheet. I mean, it's a very, very simple model that you're using. And it's a common statistical model. If you've had any stats course, right, you've probably done linear regression in like the business stats course. I believe you do linear regression, that sort of stuff. So again, it's to me, it's really too simple to be classified as machine learning. And so but it is a good way to look at something and say, this is a model, we fit it to the data, we can then test how well it works, and we can go through some of this stuff related to that within this. So sorry for our radiators. Our radiators are just a little excited today. That's this radiator back here. It bubbles like this when the heat's on and stuff like that. So you just have to kind of enjoy it. It reminds me, my office is not far down. It's up, one floor in 36 hallway, and the tin drums, the steel drums, practice just on the hallway. So there are lots of days where this is what my office just sounds like. More of a tin, steel sound, but I get used to it. So you just have to appreciate and live with this. All right. We're going to be going over these 2 learning resources today. The There's an explore activity for you to do. There's lots of choices on the explore activity because again, there are some that are visualizing data and some doing regression sort of stuff. So you can choose whichever one of these you find most interesting. Do one of these activities. Then we'll be doing this learning notebook on Thursday, analyzing the iris data. And then there's the project, the breast cancer analysis and visualization. Now, if the analysis here for Learning Notebook 2, that's made to parallel the project. So we'll do the same thing in class on Thursday that you have to do in the project. So we'll tend to look at something in the learning activity with the iris data and then look and see how you do the same thing with the data for your breast cancer stuff. So if you're trying to work ahead and get the project done, I would suggest you watch this video for the learning project, the learning notebook. That'll help you step through things. Most of the stuff you need for the project is covered in this video here. And again, we'll cover it in class on Thursday, but I know some of you are already working on the project. And so if you want to help there, that would be a good place to go. Also, there's some hints, some of the visualizations and stuff if you want some more hints on how to create those, there's some samples I posted down here. And again, we'll go over those on Thursday, but I just know some of you are working on the projects ahead of time. Okay, so let's go back up at the top and we're going to talk a little bit about this cleaning and visualizing data first in this learning resource area. So let's talk a little bit about cleaning data and organizing data. So again, often you're bringing data in for a machine learning project and you have to do a fair amount of work combining different data sources and that stuff. And there's whole areas on how to set up data to do this. We often have what are called data lakes or data repositories that are created where we pull in data from different areas and put it there, organize it together. Some of you have had SQL and you can imagine how you could bring in different tables and link them together and then maybe run queries to pull data out. And then you use that data for a machine learning project. We're not going to deal too much with that whole thing. We're assuming we've got the data pulled out and it's in some file format that we want to work with here. But when we're doing this, sometimes we have some issues with cleaning and organizing the data. So we're just going to talk about what does data cleaning look like for this. I'm just going to go to this first one from Elite Science and talk a little bit about data. And all these are going to use this metaphor, garbage in, garbage out sort of idea where if you have bad data, you often get bad models here. They often are talking about just bad data as far as just errors or problems with it. We will tackle soon a lot of problems with bias in data. And one of the things we find is that machine learning models are very good at propagating bias in your data. So if you're using data that has built-in biases in it, your model will learn those biases really well. And we often don't want that. So that'll be a whole kind of separate area. So right now we're just looking at trying to clean up the data here. So again, they're talking about removing observations. So when you're looking for the data, often they're talking observations. You have rows of data, and each row will be a single object. Maybe it's a purchase. Maybe it was when someone watched a movie on YouTube or on Netflix. Maybe it's each customer maybe is a different row or thing. Maybe like each tumor that we're trying to evaluate as cancer benign is a separate observation or a separate row. Okay, so our data is generally in a table, and each row is a different observation or object. Here we want to remove someone. So one thing we watch is duplicate observations. Sometimes we'll get multiple exact duplicates of this. Sometimes they're exact duplicates, sometimes they're not exact, but they're similar enough that we only want one of them here. And sometimes we just have errors in this data for this. So there might be just, you know, words, I call them coding things where we type in values and we might not type in the same thing. Now, a good data entry system will force you to select from predetermined things. So like maybe if you're listing out the states, what state you're from, you'd have a list of the 50 states and you just click on MN for Minnesota or MI for Michigan. And there wouldn't be a typing mistake, and you wouldn't have some people typing in Minnesota and some people typing in MN. But there are bad data entry systems where we don't have that. So like here, they're looking at the makeup of roofs. So when you put a roof on a house, you're going to put shingles generally on it. What are you going to set up with the shingles here? So here they're showing that they've got entries for composite shingles, composition shingles, and then just composition with a capital C and composition with a lowercase c here. All these are the same values, but again, they've entered them in different ways. Similarly, for asphalt, they have asphalt with the capital A and asphalt with a lowercase a. So obviously, maybe they're doing a survey and they're just having people type in, what kind of shingles did you type in or use? And they're just typing these values in here. Here, similar here, shake shingles with a dash, without a dash, with uppercase, lowercase, all those sorts of stuff. So you've got to watch for things like this that cause problems. There's a company just south of Duluth here called Nemadji Research, and their whole process is to do data cleansing of healthcare data. Watching for things like this. This is their whole business model, is this sort of stuff. Because they have, when you go into a doctor, you get a record, you visit, the doctor will type in stuff and send it off. It goes off to insurance. Maybe it'll go off to Medicare. Medicare will reject it, maybe because of something like this. Oh, you typed in, you misspelled cancer, you misspelled this or that, or whatever. Especially when we get into codings and that sort of stuff. And so that you get a bunch of rejects back, and the hospitals won't get paid for those. And so they'll send them to Nemadji, and Nemadji will reprocess them and look for issues like this in the data where they can correct mistakes. So this is big business in some areas. So, okay, besides wrong data or errors, we also want to look at outliers here and try to figure out what to do with outliers. Now we'll try to figure out what is an outlier. So an outlier is something that just doesn't fit the data. Now, we often want to keep legitimate outliers in our data. If this is real data, we often want our model to know all the values of it. But outliers often point to issues where the data was entered wrong or incorrect or with a different unit or something like that. So if the outlier points to something that's wrong with the data, then we want to certainly be removing those outliers. So often we're looking at the biggest values, the smallest nut values, the most negative, or if there are negative values and that sort of stuff. And then we'll talk a little bit about missing values. It is not uncommon for data for people to, when they're filling out forms, where to just skip areas. And so if there's part of your data that is not there, how do you deal with that? And should you fill in guess values? Should you leave it blank? Should you just delete records where it's blank? So there are multiple ways of trying to deal with missing values here. So that's another area we're going to want to kind of deal with. Just going to talk about this next one from Towards Data Science about kind of the framework we have here. They talk about this idea of validity and accuracy, completeness, consistency, uniformity here, and what those words mean with relation to the data. And then they have this workflow here that's pretty commonly done. We're going to inspect the data, get to understand it, see if there are inconsistencies, get, idea. We're going to then clean it. We're going to then kind of verify it and often then report how, run some reports to show how things are doing and that we have high quality data, hopefully at the end of this. Now, how do we do it? I'm going to go to this last thing on data cleaning, just talk a little bit of how we do this in Python here. Now, if you're haven't done much programming, we'll try to walk you through some of this. And again, it's not something, this is probably not going to be your job to do this. You're probably going to have other people doing this. So we just want you to be aware of how this works here. So again, we're importing some libraries, and the two libraries we use a lot are NumPy and Pandas here. And Pandas gives us what are called data frames here. So our data is generally stored in a data frame with our data. We often use a variable called df or some other similar variable to note that this data is in a data frame. And here we're printing off this data frame. So here's a data frame. It has a name, a height, a role, a department, and an address for some data. And each row here is a different student for this. And you can tell this is what we call anonymized. For the student's name, we've replaced it with just generic letters here. But we still have the student's height, the student's role, the student's department here listed in here. Now we can talk about working with this data, and we'll often want to I think we want to go Fruit Ninja on this data. I don't know if you've ever played, maybe are you too young to have done Fruit Ninjas? So you want to be cutting and slicing this data, right, up in different ways. So we're going to want to do that. So maybe we want to delete a column, or delete a row. How do we do that? So there's this drop command where we can say data frame.drop here. So again, we can take our data frame df.drop, and we can say a column, this column, and we're going to drop the height column. And we refer to a column's title. We put it in quotes here, and then that. Now that'll give us a new data frame. Without this, we often save that into our old data frame variable. So we say df, our data frame, is now going to be equal to our old data frame, dropping the height column here. And again, if we do a df head, if we print off this again, this prints off the first 5 rows. And again, now we don't have the height in it. Talks a little bit about missing data. In Python, what this shows up often is with data where with numbers, there'll be a special symbol called NaN. What do you think NaN is an acronym for with numeric data? It means not a number. We don't have a number there. So if we have these NaNs, that just means that maybe the person did enter something. So they don't want to put in a 0 because that's maybe a legitimate number. So they're just saying that it's empty. So NaN is basically an empty field with numeric data here. And then so we can fill in these NaNs with different things. So sometimes we'll fill them in with just like maybe 0 is an appropriate thing to fill it in with. Maybe we want to put in the average here. So there's lots of discussion on what would be a good way to fill in this. So here they're filling it in with the mean value of that column for this. And sometimes using the mean will put us a value in there that's kind of meaningless in that it's just the average. And so it's not going to throw off our machine learning models here. Again, sometimes we'll put in 0 if that's an appropriate value here. Another thing is to drop NAs, is to drop these missing values. So we can tell our data frame to drop NAs for this. So if we have a data frame variable called air quality, and we say dot drop NA, that's going to delete any rows where we are missing values here. So again, remember in our Python, anything that starts with the pound sign after to the right of that is a comment. So this is all comments that is ignored by the computer. So this is the only part. Here's the only part that's actually run by the computer. And again, here we have a data frame called air quality. We say the new air quality is going to be set equal to the old air quality, where we say dot drop NAs. And so it takes this value where we have an NA in it, and we delete it so it's not there. So that there are different ways to fill in and drop our missing values for this. Now let's talk a little bit about visualization. One of the reasons, again, you have a whole separate visualization course. If you're a data science minor, you'll be doing that. So why are we talking about it here? Well, sometimes when you're trying to visualize or we're trying to find outliers, this sort of a quick visualization will help us here. So like they're showing this as a visualization of this data and showing that this one point is way out of bounds here. And when I say way out of bounds, what does that mean? Well, we'll talk a little bit more about what that might mean as far as standard deviation, or how do you measure something way out of bounds. But just visually, we can see that this is way out of the normal pattern of data here. So that might suggest that this is somehow erroneous or bad data for that. And again, we can look at how we can look at our data set, and we can only get values where this some value we're plotting is less than some value. So we can just say, only give me the rows that fit some condition here for this. And so we'll look at ways of removing that stuff. They talk about duplicate rows, and we can have drop duplicates to do that stuff. So I'm not going to go into too much into some of this other stuff about converting data types. We're going to try to work with better data where, sometimes we have numeric data, but it shows up as string, as character data. Then we have to convert it back and forth. But again, that's kind of outside the scope of this class. So we're not going to worry about that. Okay, let's talk about 3 ways of visualizing data. And I'll just mention them briefly because we'll work on them more when we get to our projects and our learning activities. So unfortunately, well, I don't know if it's fortunate or unfortunate, but there are 3 different libraries that are used often in Python for drawing things. Pandas data frame has a plot command that'll just let you do simple things. So you can just say your data frame.plot and specify some simple arguments to create different plots here. It is the most basic, and it does some rather nice plots there, but it's pretty primitive. A lot of people use something called matplotlib. This is a mathematical plotting library. It's used a lot in Python and for this sort of stuff, and it has lots of really fun plots. You can do bar plots, You can do multi-axis plots, you can do subplots. There's whole books written about this sort of stuff. And you'll see some new types of plots as far as what's called like the violin plot here, and plots like this, which you may not have seen if you've just done maybe Excel plotting or something like that. So we'll see some of those. So that's matplotlib. It's not as pretty as some people want it to be. So there's also a library called Seaborn, which is set up to do a little prettier versions of a lot of this stuff and some little more complicated stuff. So you'll see some examples of plots that can be created with Seaborn here. Now, again, we're not going to do too much in graphics, but I will show you graphic examples out there, and we'll modify those for the project for this. So basically, we'll be taking a version that you are example somewhere else and getting it to work with your project data for this. I want to mention all three because if you Google or if you have an AI help you with it, they will sometimes, if you're searching for visualizations or doing it, they will often use one of these three libraries. This will account for most of the visualizations you'll see out there. But again, and they're all used fairly regularly, so I can't just necessarily show you one. Because in your Googling or using AI to it, they'll possibly show you different ones of these. Okay, so here's what I want you to work through a little bit with me. So again, we're in Unit 2. We're in the first thing, the learning resources. Scroll all the way down to this Unit 1 cleaning and visualization notebook, and we're just going to walk through this real quick. So we're going to use some data and just look at some code for doing this in Python. So this uses some data from Kaggle. Again, Kaggle is this well-known machine learning site where I have data, and they have this data science survey data that I've downloaded. So you could click on that link if you want to learn some more about it, but it's not that important. We're just going to walk through this and talk to you about, so I'm just going to run these cells and talk to you a little bit about it. I'm going to do this with you, and then when we get to the next one on regressions, we're going to break you in groups and have you work in groups running the same sort of stuff. So again, we import our libraries. So we import Panda and NumPy. We also import Matplot, and we call it PLT, and Seaborn, and we call it SNS. I don't know why we use these abbreviations, and I wouldn't necessarily use them, except everyone does. So Pandas is always abbreviated PD. NumPy is always abbreviated MP. Matplotlib is always plot, PLT, and Seaborn is SNS here. So we're going to use those. So in our code now, whenever we see like an SNS dot something or whatever, that's a Seaborn stuff. So just know these are common ways of importing these libraries. We're then going to bring in our data frame here. We're going to create a data frame and we're going to display it with the head command. So this is about the first language students or people in machine learning often learn or data science learn for this. So here's our language. Our first language can be Java, MATLAB, C, Sanskrit, or C++ here. And then the number of respondents here and the percent is showing up. Now, one of these is bad data in this. So one of these just somehow the data got in incorrectly. So, and again, you need to kind of look at the data and understand it to see. So the respondents, what does that term mean? So you have to look, oh, that's the number of people who responded to the survey and said that language is what they learned. So it should be a positive number and stuff like that. So again, you've got to kind of get an idea of the different columns and what they mean so that you can spot errors. So if minus 999 people said that they learned Sanskrit, that can't be right. It should be a positive. This should be a positive number, shouldn't be a negative number for it. So this Sanskrit entry must be a mistake somehow. Okay. Some ways we can look at specifying this data. We can try out different things. We've looked at the head command. There's also just a print command. This is just a print off this first language. Now, what I want you to do is go down to find this column here and try out some of these different print commands. You can uncomment them and comment another one out to see what it does. So now I'm just going to say first language dot head, and that will print off this first line, the head here. If I say first language head 10, that will print off something, print off the first 10 values of this. If I say first language dot tail, and what I'm doing is I'm just using the pound. The pound sign will make a line a comment. So if I put a pound sign at the beginning of a line, that'll ignore it. So all of these, like right now, all these lines are going to be ignored, and this tail is the only thing that's going to be run. So the tail should show me the least common languages in this list. Or the last ones. Maybe I'm not sorting it. So the last ones here are Python and blank. Now notice here's not a number. So this is another some data we should clean up out of this. Okay, so we can use different ways to see the tops and the bottoms of the data here. We can also look at different columns. If we want to just look at one of the columns, we can say first language. If we just want the respondents table or column, I can say first language dot respondents, and I'll just show that column here. You can also specify it in different ways. Oops. You can just say first language dot respondents or first language bracket and then put respondents in quotes. Both of them will work here. So. Now we're going to get a little more into this Ninja stuff with the iLocation idea. And with iLocation, we specify what columns and what rows we want to have here. Oh, I should say what rows and what columns. So we always specify the rows and the starting row and colon, the ending row, and then a comma, and then what columns, the starting column and the ending column. So this will show us columns 1 through 2 and rows 2 through 5. So that's what this does here. Now, with all of these, we say row or column 1 through 2, but not including 2. So it only, if we say something like this, it's only going to show us one column. If we went from 1 to 3, it would then be columns 1 and 2 here. And again, these rows, starting at row 2 and going up to, but not including row 5. So this is 2, 3, 4 rows here. So again, this will let us grab any chunk of the data. If we want to do like all the rows, we can leave that blank. We just have to have a colon in that place. So like this, let me go back up there and do that one. So this one here would be any row, but only columns 1 through 3, not including 3. Likewise, if we want to do only certain rows, we can do this And then we don't actually have to specify the columns. We can just say, I only want rows 2 through 5 here. I generally have trouble remembering how to do ILLC, so I often are searching or having AI generate it. But I find it very helpful to know there's this command out there so I can then ask or Google or search and say, oh, I need to just select certain rows or certain columns. How do you do, I can ask some Google or an AI, how do I, remind me how to do that with the iLock, iLocation command here. The next thing we're going to look at is printing out what is called the shape of the data. Here, sometimes when you're organizing big data sets, we just want to know how many columns it is, how many rows it is, and the shape will do that. So the shape is just kind of the size of a grid. So if I say print, the shape of this data is the number of rows and columns, so that's just text I'm printing out. And then I print out the first language dot shape. That's what I'm printing off. So if you say a data frame dot shape, it'll tell you the shape, and it'll tell you the number of rows by the number of columns. So this is 9 rows, 3 columns wide here. Another thing is you can count the columns or count how many rows are in each column. If we say first language dot count, it'll count that, and this is good because it'll show you if there are empty columns here. So here it's calling there's 9 values in the language column. There's only 8 in the respondents column, and there's 9 in the percent column. So this is suggesting to me that there's some problem with the respondents column. One of the rows probably has a null. And if you remember, we see that here, there's a null value here in the respondents. Another way to get this information is just say your data frame.info, and then I'll list out things like the number of non-null counts here for each of the columns for them. Now we found some nulls here. If we want to remove those, we can use this drop NA command. And so again, if we have our data frame, we have to decide with our data frame when we're cleaning it, do we want to just replace the current data frame and do it again? Sometimes I like to create a clean copy but retain the original. So here's my first language data frame, and I'm saying drop NA. But rather than just storing this back into first language variable, I'm creating a new variable called first language underscore clean. And that'll be a cleaned up version of this. Now, if I wanted to just use the same, I can just take that same data frame and replace it. I could say first language equals first language dot drop NA, and it will take that data frame, delete any rows with empty values, and resave it with the same name. But again, sometimes I'll want to keep it as a separate clean variable. So when you're looking at data analysis, try to pay attention. Are we overwriting our data and always using the same variable, or are we creating a new variable that we should be using here? So now here, rather than saying first language dot info, I'm saying first language underscore clean, which is my new variable. And now it only has 8 rows in it. Well, look at getting the largest and smallest values. There's a command for the n largest values, the n smallest values. So again, this is sometimes good to look through. Now, sometimes this is good. Python's really popular. So this is a big number, but that is still a legitimate value here. But if I look at the smallest, Sanskrit is a negative value. So that does show me that that is an erroneous value, because I know that should be correct. So again, if I want to find all the values that are like less than 0, I can do that. I can say go my first language clean data frame and find every spot where the respondents is less than 0, and it'll print off all the rows that have negative values. Now I can remove those rows here. So I can use something like this. My new data frame is going to be my first language clean, but I'm only going to select from first language clean, the respondents is greater than 0. So this will only select the rows where the respondents is greater than 0 and remove any of the negative ones. So that's one way to report that. Another thing I could look at is look at the index here and remove a value based on the index here. So here, Sanskrit, the index, the kind of the row number, the index is kind of like the row number on the left side. It's 3. So if I want to remove row 3, I can just say first language clean dot index 3, and I want to drop that. So I could say drop, and then I specify which index I want to drop. So again, there are different ways of cleaning this data up, and we'll continue to look at more of these. Now, again, if you've done some coding, this might be easier to follow. Look at my coders out there, and I'm not getting a lot of positive looks, right? If you haven't done coding, we're gonna have to some of you know, we can try to walk you through this, or you can kind of learn from examples, or we can have AI help you with this. We are seeing more and more now in the last year using AI as an assistant for coding in different ways. So knowing enough so that you can set up this or ask the AI to do the right thing. So we'll talk about that when we get to on Thursday, how you might be able to use AI to help with this sort of stuff. Okay, that's all cleaning the data. Let's talk about visualizing the data. So we're going to bring in some data here, and we're going to visualize it for this. So we talked about different ways of visualizing data. So if we have a data frame, we can just say plot, and it'll plot some sort of graph, generally a line graph by default. So if we just say first language dot plot, it'll often just create a line graph of every column in the data. That's often not what we want. We want to, refine this. So we might say first language dot plot dot bar, and then specify some values here. So the x-axis is going to be the language column, and the y-axis is going to be the number of respondents, and we get something like this. And we get a little key up here, and it shows different languages, and it shows us Python in data science is by far the most common language used. That's why we're using it in this class, obviously. And it doesn't mean that some of these other languages aren't useful. SQL, R, Java, there's still lots of people use those, but Python's very common because it's used by a lot of intro courses, and it's relatively easy to get started with. Okay, so these are just the plot that are built into the data frame. Let's look at using Matplot. So if you remember, when we bring in Matplot, we import it. Matplot, import Matplot as PLT. So then when we're using it, we say PLT dot, and then a type of chart like PLT dot bar. And then we specify things like the columns. And again, this format is slightly different than this format. Here we're saying X equals and Y equals the column names. Here we're saying the data frame dot, or in bracket, the column, and first and second. But we can create basically the same chart with Matplot here. We can also create a pie chart and that sort of stuff. And again, we're using this PLT. So anytime you see PLT, that's gonna be the matplotlib version of it. Now, one reason why I try to tell you that is that if you're trying to solve an error and you're either Googling or asking AI, it helps to be specific about it and saying, here's a command that's using matplotlib and it's generating this error. Or here's a command that's using Seaborn and it's generating this error. And that'll often help you find the correct solution to it. So here's some things with graphing with Seaborn here. Oops, here. And again, we often are bringing in Seaborn as SNS, and we're doing, often Seaborn will have a number of different commands to set things up and then a plot command for that. And again, they tends to be nice, visually appealing graphs for this that uses Seaborn. But again, we often have a number of Seaborn commands that are creating a graph and setting it up and defining characteristics of it, and then we're plotting that at the end. So. Okay, any questions on this? I think I've been talking too much. So let's get going over here to our next area, which is, I'm going back to Unit 2 and going to Learning Resources, Correlations, and Regressions here. And I'm going to break you up in teams. Now, eventually, I'm going to spread you out in teams so you get to know other people. But again, I want to first make sure you know who's sitting next to you and that sort of stuff. So today, again, we'll work with teams with what's sitting next to you there. I'm going to talk about this stuff for a little bit. And then I want you to go down here to the bottom to the POGIL notebook and open that up. And that's where you'll be working with teams. And we'll just do teams of 2 today. I think that works fine. If you're sitting by yourself, you're certainly allowed to work by yourself if you want. You know, you can pair up with someone else who's sitting by themselves. I'm fine either way. This isn't a mandatory teamwork sort of stuff here. So, okay. Do you guys know, do I have to talk about correlations? You guys know what correlations are, don't you?
Yeah.
Right, you've seen correlations before. So if you don't know what correlations are, read this sections. So again, and you know that we measure correlations with this coefficient between 0 and 1 here. It can be +1 to -1. You've probably seen enough things that correlation is not causation. If you haven't, click on some of these fun examples of correlation is not causation. So like this is the relationship between ice cream sales and shark attacks. So it obviously shows that you should not eat ice cream if you don't want to be attacked by a shark, sort of stuff. So again, if you're not familiar with what's the difference between correlation and causation, look at this examples here. There are some nice examples of correlations here. Then let's talk about regression. And again, I don't think you covered this in high school, do you? Have you had a stats class or somewhere where you covered regression? Some of you know, yes? What? You think you have, yeah. So we'll just mention it a little bit because again, I don't think everyone has seen this, but I'll just go over the basics of it because you're going to go over it in this worksheet more. So a regression is like the most basic model where we have some data and we want to fit a line to it. And then once we have that line, we can use that line to predict values on it. So again, we there's a mathematical method to find a line that goes through all this data that minimizes how far each data point is from this line here. So this is kind of showing the data points, this line, and then these little vertical lines are the distance from each data point to our linear regression line. And again, we can point that line in different ways to try to find the minimum value. And we can do that in multi-dimensions, and we can do it with non-linear regressions where we're using some sort of a polynomial curve or something like that to do that. Now, once we have that line, we can make a prediction. So if we look at our average temperature and our carbon dioxide levels, and we find this line, we can then make some prediction where if the average temperature is about 12.5 here, we could say probably the carbon dioxide is at about 390 or 385 parts per million. Or if we say if our carbon dioxide levels is getting up to 400, we can predict our average temperature will be around here or something like that. So again, we can do different predictions once we have this line that's trying to fit this data. If you want to learn more about how we calculate linear regressions, you can go through that. There's some really neat algorithms there, but you don't need to know how to do them. I will want to mention just one more thing. Linear regression sometimes gets confused with what we'll do later on, which is time series forecasts, where we're trying to predict some fluctuating time, like a stock market value, something like that, and we're trying to predict time series. And here we're not trying to draw a line through it. We're trying to recognize a complex pattern in time going up and down and left, and we're doing that. And that is not, it's more advanced than linear regression there. So, the line we're trying to predict, you can kind of see the red line is a prediction line here. And so this red line, prediction line, is trying to go in here. And it's, again, much more complicated analysis than that. So we will use neural networks to do some time series forecasting here. But again, this is more advanced and more inside the scope of this class than just simple linear regression is. Okay, so the last thing I want you to do in this class is to work in pairs if you want, and do this POGIL activity. I don't know if you're familiar with POGIL activities. POGIL is just short for process-oriented guided learning, interactive learning. Yeah. Inquiry-based learning. And that it is just some way for me to teach you without talking to you, where you work through problems in often small groups and try to solve them. So in order for you to learn this, you need to open up the notebook and the worksheet. So there'll be a notebook here, and there'll be a worksheet. You can put the students' names here and just have, if you're working with pairs, it's kind of nice to have maybe one of you working on the notebook and one of you working on the worksheet. Now, sometimes I have these nice little slips, and I'll assign you roles. Those of you who have me in class are used to that, where we'll assign those. And then I'll ask you to, well, the spokesperson tell me this or that. We're not going to do that today. We're going to do a real kind of informal POGIL activity here. So you can decide if you want to be the spokesperson or if you just want to do these roles. So don't worry too much about the roles. I do suggest if you're working with a partner, share the document with the partner so that later on, if you want to review this or stuff, you have access to it. It hasn't gone away at all. So it would be nice to open these up, share it with your partner if you have a partner, and work on it. And then your goal is just go through the notebook, run the commands here, import the data, talks about correlation, then they'll get down to some questions here, like here we're plotting this regression line, seeing if you understand, and doing a regression model, setting up this regression model, fitting the model to the data here, and then making a prediction off of it. And then we'll ask you questions about this. So using the regression model, predict the values for a 4,000 square foot house and a 6,000 square foot house. So you should well go back up here and predict those values or look at these and see how that works here. Okay, so see if you can work through this. I'll stop talking and help you if you get stuck at times. Oh.
Oh.
Yeah, we're just going. And yeah, you don't have to turn anything in with that. It's just a learning activity. So, okay.
I probably watched the videos after that. It's no problem.
Right, that's a big good thing to do. So, okay.
And also, just a reminder about the email that I sent.
All right, yes. Oh, yes. Not really. So Chris has, I think. Yeah. Yeah, so, yeah, I haven't let, I don't, they don't let me do much web stuff these days.
Okay.
It's been
So
years
more
since-
like
yeah.
Python logic.
Yeah,
Okay.
so,
Sounds good.
okay.
Thank you.
That lines up. Let's just. Multiple instruments. First. So. Yep.
No, the 1 million goes with that. That's what you're, sorry.
But I think the X, yeah. So basically on contact, my grade, but with here, you're still so far. Holy balls. Holy fucking balls. Mine is, yeah, so basically. It's basically just. You know, it's kind of all. Like thinking it's still. But it's like. You know.
Yeah. Section 2. Oh, okay. Oh, one. 4,000 square foot. 6,000, it says right here. It's
Yeah.
one or just like that. More. Like what I'm storing. Well, they do give us 2 stories. The point. The 3.
Yeah. Yeah, we're gonna do this one. It's very close. So, yeah.
Or I think it's this one.
So basically,
I am so like for
using square.
mine was not that.
Check.
Go to.
They're still Yes.
Yeah. Yeah. I didn't find the drinks I changed it to
Well, being zero is not all over the place, and it's not one, it's not.
Just a quick note, there, right away for the first question, you go down and you're predicting from this model. And there was a 6,000 here, that should have been 3,000, so. Because again, we're predicting a house with a 3,000 square foot house. If we put in 3,000 here, we should predict a house value of about 775,000, 776. And then you can change this 3,000 square feet to other values to predict other value houses. So I think you have to do a $6,000 house. There.
Okay. Go back up, scroll up today. Don't move. Under. Stop moving.
Okay. So this one. Like that. Lots of points.
I'm lost. Yeah, that's what we were doing. I'm confused by what this one was trying to say.
That's what this, so this is our
Okay.
original model, and we were predicting that one. That changed up to 3,000. So that's a 3,000. So again,
Okay.
we're looking at this model. And we're just saying, it makes the line, say 3,000 is roughly 1.7 or whatever.
Yes, okay, now I'm.
And then if you change it to, or not, 3,000 is actually just less than 1.7.
Yeah.
And then change that to 4 or 6 or whatever else you want.
Okay.
You know, so it'll go along that
So
line.
it'll, we're predicting it, comparing it to see if it's similar value.
Yeah, well, it will, you just look at all the houses that are on that line. And then you can tell it, any spot along there.
Yeah.
Say 4,000.
Would be email.
Let's just
And
say
it will go up to that line and go over.
Say
and say,
train. And.
Yeah.
Or just like.
Alright, so.
Yeah, sure. Yeah.
So I'll just warn you, this is like California size houses, not Duluth size houses. Here, I think I live in a giant house and it's 2,400 square feet. In Duluth, and there's a lot of houses in Duluth that are under 1,000. There are a lot of houses that are 800 square feet and stuff like that, 600 square feet.
And then this one I think is team with the train. That's right here. Variables. And. That's a big in the train variables and. The regression. One. This is. This is giving us.
Yeah.
Yes. And from. What are the Marie property? Right, you're going to. Wow. Because like, look at this, this is how it all changes. And I just wanna say like, there's too many variables. Yeah, there are too many.
So that is
Different.
So drop it is. Yeah. So.
Okay, I'll come right here. One of us. No. Let's see. You've been like answering stuff before. Oh, it changes every time. Cause it's using, it changes the features. So it doesn't really matter. Are you guys? Oh, that's that. Where does the randomness come from? So it builds in.
It's your, I'm just confused about the. Are you talking about running it, your thing of like that you were showing
Yeah,
up
like,
there? Like run it, but when I try to run it,
I don't know, it's just playing
it just
different.
gives me an error for any
Yeah,
of the numbers.
Probably have to go up to the models, the lines above it, so run this.
Cause like some it'll pick one with 3 bedrooms and some it'll be one with
Okay,
2
all right,
bedrooms. And that's gonna change that.
Basically, let's start at the top and make sure you're running each one.
What color?
Then run this one. There. Okay.
Right.
Yeah. we're done. Now we're just- Yeah, and create just model, results. And under here. Okay, so now you can change. So it has to load in all the data, so it's not those cells.
That's annoying when I know what it's gonna put out though, that's that.
Yeah. Yeah.
Me.
Okay. Right.
Whoa.
Yeah, that's worrying about this. This thing, it is just formatting this data. I guess, what it's kind of doing is that it's picking a.
Yeah. Oh my God. Hey. Yeah. I can hear it. No. No, I never had her vote either. I'm surprised.
So just,
Do you ever have
the
a?
main thing I want you to know is that it's picking up script.
Right. Both sides of the 2 classes.
Yes.
What do you do when you're done?
When you're done.
Yeah.
You go over and do it again because it was so much fun, right?
Yeah, so much fun.
So. This is all we're gonna do today, so.
Okay, thank
Not
you.
to retreat, not the max, it's already leave earlier, but he had, a point.
Oh, okay,
He had an important point.
Mm.
So that's why.
okay. Since we got it.
Yeah, so if you have an appointment due and you're
appointments.
done with the worksheet, you can leave also.
Thank you.
Yeah.
Okay.
I think
Yeah. Generally, it should be like 8% of how many houses you get. Okay, or not, I mean, we're not really getting it, we're not getting it correct, but it's kind of some measure of how close we're getting. How so, one would mean we're getting every house, predicting it exactly right. And zero would mean we're getting another house. Very good. So negative is probably not, like, it's not, the year bill, it's probably not a good predictor of the price. And that makes some really good houses are worth a lot of money. And some really new houses. It's really hard to predict based on that. So year built is probably not a good factor.
And above the. You're in the wrong model. Yeah. If you like, look at, sorry, the model above the. I didn't know if you had to put it. So then try to work on the front. I don't know. So I said. It's like square foot. And make me. I just want to replace. Well, it says above.
Like here, using like year built, and using year built.
Yeah,
So I should replace where these.
Year built, yeah, and then you should replace one of the other, it says year built, choose something else.
Okay, and that's what I'm doing for up here.
Yeah.
Or
Things, take these, right into them.
I'm just confused on what it.
Oh, that one is actually.
That's right there.
Yeah, scroll above. You go up, what this is trying to show you is that when you run this. It is somewhat random, so if you run it again, it'll give you different values. It randomly picks some houses to test and train. And so I want you to see that
So
it
just
gets,
put the numbers.
right, put the numbers there. And that's what we'll have to run some of our models multiple times, because when we run them, it'll pick some random values to test it with. And if it picks good random values, you get a better number, and bad random values, and so if you run it again, you'll get slightly different random results.
Oh, I don't.
Okay.
Thank you.
More business today. Okay.
So you.
That means,
Yeah. I'll show you.
which class is actually.
Yeah, I was confused about it too.
So I did.
So basically you go right here, you go up to this one, number 2. And it just shows that this number right here will switch. Because it's just blocking like different houses with similar qualifications.
You just run it.
So you just run it and you put in the 3 different scores that you get. And I rounded mine. So I really should have.
It just slides.
Yeah, so it's like right above that class 3 in the bottom there.
How they say come.
Oh, so.
Did you run everything? You have to run it, everything from the far, the start. I had to do the same thing. Cause like, it like builds off of it apparently. Cause you run everything from like the very beginning. And then just slowly go down. No, I feel you just. I did. Oh, also, I said, I made like a Google folder for the breast cancer thing. And I put the information in there. I just figured since we were talking about it, why not just do that now?
No, I don't think that. Yeah.
I didn't know.
Yeah, that's all I want to say.
Why is there? James said it'll be X, Y, C, so the axis of the 0, 1, 2. If you kind of something like this,
The what? But you get the best. Oh. Think so, and I. Think so. Oh, okay. Oh, sorry. My God.
I think one bit of the way is looking.
I deserve a nap.
You do.
I am so done with today.
Is this your last class?
Oh, and if I had any more, I'd be done. My car is having so many problems right now. Of course, I want to drop is having all sorts of problems because apparently you can't drop a 2-credit course anymore. And I'm just. I want to strangle someone.
I wanted to ask if the research class,
Yes,
do we have to register ourselves?
let me check my email. I sent email out to the registrar to have them do that. And I didn't check yet today. Okay, so they just created the CRN for it. And you should be able to add it through Monday. I'll send this out, so I'll send out the
Okay.
CRN and have you add it, okay? They just created the CRN.
Thank you.
Yep.
You want to hear about my hectic morning?
Yes, I want to hear about your fun hectic morning.
So. Of course I switched, right? I switched my thing, like I'm in the process of like officially joining the new version of the major, right?
Right.
Well, I picked up classes last Thursday, right? I dropped everything and I
Right.
picked it up. Well, I picked up 2, both of them happened to be 4,000 level courses, which I didn't realize.
Oh, okay.
And I was like, okay, this is fine, like, I can do a big workbook, but then I actually like wrote down all of my work that I'll end
Yeah.
up having for everything. Oh, Ally needs you.
Okay.
I'll stop talking.
We're,
Just for you,
we're
I-
doing more things. Um, so basically, if when we're in our model, we specify the X and the Y values, we, the X values can have is like, I don't know, an array of arrays. Right, or you know, it has a collection of columns there, okay? And, the output, the Y, is always a single one, so it's a single array. I'm gonna put it into, thing, so when we select this, we select a column, it gives us a single array. When we select this, it gives us a single array also, but we need it to be an array of, that holds a single array. Or a column, you know, a list that holds a single list. So that's what the reshaping does. Let's not worry about reshaping so much. Just because, just know that when the X here is often an array of, it can have multiple row columns in it. There. Reshaping with the -1 is one way of doing that. Let me show you like. Like, it's the same reason why here we specify bracket 30. Okay? Why do we have square bracket 3000? Because usually we would specify a list of lists there, and we have multiple values in that list. And we can have then multiple lists in that. So we could say this list and then comma, another list, another list, okay? So, okay, that's all I can give you right now.
Yeah, and so then I go and I dropped it, right? I picked it up, I picked up the new courses,
Uh-huh,
and then I realized that like, shit, like, I'm gonna literally be drowning in work.
right,
Which I could make do, like, I could do that,
but you
Like,
don't, right,
but I won't do my best work,
Yeah.
and I try really hard to get all A's, like,
yes.
I was pissed at myself, I got a B last semester.
Uh-huh.
And so I was like, okay, like, I have time, like, I have until the 29th to drop classes.
Right.
Well, it turns out because it's a 2-credit course,
Oh, uh-huh,
I can't, like, drop it. But I can't just, like, give up, like, one of my 4-credit courses because
right,
then I won't graduate.
yes,
Or I won't, I might be able to swing it, that's like, in the way.
right,
And so I'm like, okay, well. I go to my boss and I'm like, I'm sorry, I'm so stressed right now, like,
Right.
if there's a tour, please don't send me, like, I
right,
can't
yeah,
try to figure out this, and this. And like, she's like, oh, why don't you just go to the registrar's office to like talk to them about it? It's like, oh, I didn't even know like that was
yeah,
a thing.
right,
So I go this morning to do that. And at this point, I've already talked to Richard Kaya and he's like, yeah, go for it. Like, drop it, let's do it. And she goes and she's like, oh, like, yeah, so right now you can't drop the class by yourself because it's past the date for 2 semester
Right.
credits, which is listed nowhere.
right,
And she's like, yeah, you had to do it last weekend and not last week sometime and blah, 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 blah. I'm like, okay, well, I've never gone to this class. I joined it Thursday when, like, and at that point, like, I literally haven't been in.
Right, yeah.
And she's like, oh, you haven't? Okay, then you should be eligible to drop it still, because it's, like, you joined late and you did it as soon as you realize within a reasonable amount of time.
yes,
And so I go and we work together to make this email and we email Richard Kaya and be like, hey, can you tell, like, in confirmation, like, can you confirm that I've never been to class and I joined the
right,
mistake?
yes,
And before he even has a chance to respond, academic advising, because I CC'd them in, because that's what
Yeah,
the registrar's office told me to do. They're like, oh, yeah, I just need this in confirmation, so that way you can withdraw from the class. I'm like, no, I'm not withdrawing. I'd rather stay in the class and try, like, do my best and like drown in the work than withdraw from it. I
Right,
don't want that
yeah.
on my transcript. But I was told that I could drop it, like, not,
Right,
like,
yeah.
that I would have no
Right.
adverse effects. Why
Yeah.
are you?
Yeah,
And so I'm trying to like confirm with her, the person in it,
who is it, Janessa? Who are you
it's
talking?
Lindsay, who's.
Lindsay,
if
okay,
it- And I have a meeting with David Bauman, like I can wait one more day, cause I already have everything in
okay,
writing,
yeah,
but like, I don't wanna accidentally. Like, be under the impression that I'm dropping it and then
right,
have it result in a withdrawal that I don't
yeah,
know can be
right,
fixed.
yes.
So I'm
So-
waiting for an email back, and I'm like, and then on top of all that, my car's having trouble.
So-
So last week, my car wouldn't start,
Yes,
so I was trying to go to our houses, because I'm trying to buy a house with my dad right now. And I was gonna go tour this really nice house that I really wanted to go to. And my car like will turn on, like the battery will start,
okay,
but my engine won't turn on.
oh, okay,
So I'm like, okay, what the hell? So I called AAA. And AAA is like, yeah, so this is actually a starter issue, not a battery issue. And you're gonna need to get towed and have work done. I was like, well, screw this, like that sucks. So I go do that, I call my, like, the place I go to All Star,
okay,
and they're like, oh, we don't have room until this Tuesday.
Mm.
So I was like, okay, and this won't like kill my battery and like destroy my car if I just let it sit in the
Right,
parking
yeah.
lot. They're like, no, you should be fine, like whatever, like you should be totally fine. So I'm like, okay, I'll do that. So I canceled AAA for the towing company, and like, I was like, okay, I'll just leave it in the parking lot until then. Well, yesterday I go and call the AAA to get it towed, and the guy who's towing it is like, let me try to start this and fix it, cause that way,
right,
like, if you don't need to tow it, let's not tow it. Plus, you're in a really awkward spot, and I
Yeah.
don't wanna do all that work. I was like, okay, bear, like,
Yep.
do what you wanna do.
right,
So he gets it working. He's like, just don't turn off your car until you're like in the parking lot at the place you want to go. I was like, okay, cool. So we do that. And today it's supposed to be fixed at like 2, and they called me at like 10, and they're like, hey, we were trying to check out your car just early because we finished some other stuff, and your car is starting fine. I'm like, okay, what do you mean? Cause like I've been trying all week and
Yeah.
it's not doing anything. And they're like, yeah, it's working fine, like we tried a handful of times, we tested your starter. Like, your starter's fine, like, you could replace it, but I don't wanna advise that
Right.
because there's nothing wrong with
Yeah.
it. I was like, okay, so then what's wrong with my car? And they're like, yeah, we don't know. I was like, what do you mean you don't know? You're, like, this is your job, I know
Right.
nothing about cars.
right.
Like, I live 6 hours away,
Mhm.
like, I'm not. Like, I have to go home for different things, and like,
Uh-huh.
what do you mean you don't know what's wrong with my car? And they're like, yeah, well, we could try this, or we could replace it, but I don't have an estimate yet, and honestly, I wouldn't do that. I was like, okay, like, can I call my dad? Like,
Yeah.
give me the answer right now. I'm like, oh yeah, go call your dad, like, you're good, like, by the time you call back, we'll have an estimate and we'll see what else is up. So I call my dad goes, have them check the battery. I'm like, okay, but like, what is that gonna do? So they said they're gonna check the battery, but now I'm waiting for a call back, which is like. I'm just stressed,
Yeah.
and
I don't know that much about cars, but I've done a lot of cars in northern Minnesota, and I would say your batteries either started to get weak. Because it just didn't have a time to charge very much, or else it just, getting a little old, and we had that really cold
Yeah.
weather,
that's what I was thinking. 'cause,
So,
like,
and again, sometimes when it's really
Yeah.
cold, I'm surprised AAA should have just come out and jumped it.
They did, and it didn't work the first time. That's when he was like, oh, it's not working like the first time.
Oh,
We
they
like tried
came,
it like 4 or 5 times.
wow, huh,
And he's like, yeah, it must be your starter, cause your car's like, and he even went in my car and tried. it.
yeah, right,
And he's like, your battery's turning on, it's your
Yeah,
engine that's not
huh.
rolling over.
yeah, I don't know, that's weird,
And
so,
then, yeah, and then the second guy who did it, who jumped my car,
Yeah,
like actually
yeah.
got it to work, he had to try like 50 times, like I swear he was just
yeah.
twisting my key. I was like, oh my god, please don't explode, car, please don't explode.
Mhm.
And like, my car always stutters when it's cold, but like,
Yeah,
it's never like just not
Right,
Sure.
yeah, so
Anyways,
frustrating. Well,
LOL.
let me know if you have trouble getting that class
Oh.
dropped.
Oh, you will be hearing about it.
Yes.
You know
There,
me.
because there's something called a registration appeal, so if all fails, you know, when they work this out and if this doesn't end up the right. There's a registration appeal form where you can fill it out and repeal how things ended up.
Okay,
So again, just know you have, you know,
Okay.
down the line, you have another option.
cool. Thank you.
I was wondering if you had time. The efficient requirement.
Right, yeah. So remind me what you were going to
I
do.
was gonna do DigiKey.
Yes,
We're gonna begin on the 10th in June.
okay,
So then I think we were trying to figure out if we had to like sign up or something.
right, so what do you have is? Cause you can sign up for different amounts of, well, you have to sign up for one credit limit. But you can do additional. When are you looking to graduate?
This May.
This May?
Yeah.
Right, so like, and you just needed it. But yeah, and we were thinking, because you're graduating this way, is putting it, or actually having you register
Yeah.
maybe this semester, right?
Yeah.
Right,
If I can make that possible.
yeah, so, is this your B number, the 798-413?
No. 007
What's your last name?
Muhammad.
Yeah.
There we go.
Okay. 787-441. Okay, let me see. We can get you. And we're gonna do spring semester. So right now you've got, so the problem is right now you've got 18 credits.
Yeah.
Right?
Mhm.
So adding another credits, so you know, it's a flat rate between 12 and 18 credits, but if you're over 18, you have to pay more
Okay. I see.
for it. Let's see, what other, and let's see, how are you setting up? And you have, so.
I think I needed the software quality assurance.
Yeah,
Yeah, I need.
yeah, for your concentration here. So, yeah. Let me talk to Chris about if there's some other options. Well, why don't you talk to financial aid? Can you go down to talk to financial aid and say if you are at 19 credits, what would that be an issue? Okay, well, and if it would cost us, what it would cost.
Okay.
And ask them if, the other option would be if you were to take one credit over the summer.
Mhm.
Okay, so see if you can do either of those, either take another credit now or put it over the summer without much cost, then we can do that.
Okay.
Otherwise, we can look at somehow waiving it or something like that,
Yeah.
because again, it looks like you have enough credits to
Yeah.
graduate
Mhm.
without that. You
No,
just-
yeah, because
Yeah.
I'm pretty sure I should have enough credits. to
Right,
graduate,
yeah,
for sure,
right,
it's just that-
yeah, right, so let's,
Okay.
why don't you ask financial aid if you can get it for free,
Okay.
we'll get it in there.
Okay.
Otherwise, we'll work it some other way, okay?
I'll go try to talk to them. Will you be in your office or would you be?
Yeah, I got another class at 2
Okay.
to 3:30, so in this